Aloha and welcome to our video entitled Representing Earth's Surface. In this video, we're going to introduce the lesson by the same name in your Earth Science class. The goals for it will be to locate points on the Earth's surface by their latitude and longitude. We'll be able to describe the advantages and disadvantages of different types of maps. We'll explain what makes topographic maps different from the other types of maps. And finally, we'll describe how technology provides the ability to more precisely analyze Earth's physical properties. Okay, so the first thing we're going to talk about is the global grid and what that is. And what the global grid allows us to do is it allows us to find any place on Earth and define that place and provide the location for it so that every place on the Earth is going to be unique. And in order to do this, because the surface of the Earth is going to be two-dimensional per se, we have to have two different things that we'll use. And those two things are going to be latitude and longitude. Now, this middle picture here kind of shows us the total global grid that we have, but we're going to start over here and we're going to talk about latitude first. Now, latitude are going to be these lines here that run parallel with the equator. And what they do is they measure how far north or south from the equator we want to go. So it gives us a direction of north and south. Now, one way to remember these ones, we said that these are our lines of latitude, and those are the ones that lie flat. Okay, they lay flat with the equator. Now, we said we need two things. So the other one we need are going to be longitude lines. Now, this one over here is our longitude line, and all of our lines are going to be the same length. They're all the same length. They're all long, just like each other. They go from the North Pole to the South Pole, and we have a start in here. This is called our prime meridian here. And what longitude measures is how far east or how far west it's going to be from this line here. Now, because there's 360 degrees on the opposite side at 180 degrees, we kind of have 180 degrees east and 180 degrees west, and we call that the international date line. So it has its own unique name. So 0 degrees in latitude is going to be our equator, and latitude is going to measure how far north or how far south. And we use longitude from the prime meridian to determine how far east or west we are. So if I know from a point of 0, 0, I can measure how many degrees north, how many degrees east, and I can find that position there. And that's why we call this a global grid, is it gives us the ability to map out or to specifically plot any point on the Earth. Now, maps are great. They help us a lot. They help us with navigation, to find things, to describe things, to show what things look like on the Earth. The biggest issue, though, is if we go from a round spherical object to a flat object, we have problems. Try this at home sometime. Peel an orange and then try and lay the orange peels together flat in a usable shape so that you can actually see how it would look like. And that's kind of what we're doing with maps. The problem is when we take something from this round shape over here and make it into a flat shape like the map we see here, we end up with what we call distortion. So things are going to look a little bit different, a little out of place. Okay, one of the first map projections that was out was the Mercator Projection, and it's still used an awful lot today. What makes the Mercator Projection useful is we talked about this global grid, and we have our lines of latitude that are here. And notice that they're parallel. They measure how far north or how far south something is. We also have these lines of longitude, and our lines of longitude in the Mercator Projection are also parallel, and they're going to measure how far east or how far west something is. Now, in a Mercator Projection, our lines of latitude are perpendicular to our lines of longitude. So you'll see that we have these nice, even little corners everywhere, and that makes it really easy to find things and use the global grid to get there. The problem is the further you get from the equator, we have this distortion. So you see things like Greenland here, and look how big Antarctica is here. Those are just distorted, they're blown out of proportion size-wise, and they're made to look a lot bigger. So that's where our distortion is greater at the poles. One way to try and correct that distortion is to use what we call a Robinson projection. Now in a Robinson projection, take a look here and notice that our lines of latitude are still going to be parallel with each other. But notice the lines of longitude. We have our prime meridian here, but the rest of the lines of longitude all have this little bow. And I'm going to draw this one here. Then we'll notice a bigger bow as we go a little bit further away from it. So instead of it being perfectly perpendicular, we have these little bows to the line of longitude, and that reduces a little bit of the distortion that you noticed up here at the poles. Another common type of projection is a conic projection. And a conic projection is going to be if we took a cone of paper, and here you can see where its shaped is, and it's just laid over the globe, and then we project the image onto the paper that way. And what you notice is where it's contacting the globe, so we're going to see that line right about through here, is where it's going to be super accurate. The further we get from that point of contact is where we're going to see more distortion. Okay, so we'll see kind of a variation and kind of a change that way. These are going to be really good if we want something in this part right here. So if you wanted to make a navigation in that part, a conic projection would give you an accurate representation of what it looks like. Now the mnemonic projection is if we were to take a piece of paper and just set it on one point on the earth and then project the images out. And that's what it's kind of showing you here, is we can show this projection outwards. Now this is going to give us a really good representation around where that was touching. These are used a lot in navigation because it provides us with an accurate representation of that area, and we can use that to determine the distances from one place to another, which is really good. So that's one of the things I want you to see, is that we have these different projections. They all kind of do something a little bit differently. They have their benefits. The further you get from that point of contact is where we're going to see the most distortion. So that's where those maps become a little less useful. But right in this area, it's good. If you were trying to do something out here, you'd probably want to either move the piece of paper, draw another map for that area, or possibly use a different type of map. Okay, so a different kind of map that we're going to talk about are these topographic maps. And a topographic map is kind of neat because it takes that two-dimensional map that we've been talking about, but it adds that third dimension, that dimension of elevation. So if we take a look down here, we can actually see that we have a landform. And I kind of have a nice little picture here so you can kind of see what it is. We can draw that on the map. It would look basically just simple. There's nothing there. There's no water or anything like that. It could be just a flat section of the map, and it would just look like that. With topographic, what it does is we add these contour lines in. And these contour lines give us a clue on elevation, how high something is above the surface of the oceans. Okay? And we'll notice that here we have a little bit of an incline, and we can see we go from 280 to 290 to 300 here. Then we have more over here, 310, 320, 330, and it all kind of lines up with the picture. But then we have this little depression here, and we can see that's marked on our map this way. So topographic maps are really nice because they'll give us an idea of elevational changes. That's what we would use them for. Now the final kind of map we're going to talk about is what we call a geologic map. And a geologic map is important if we want to know what kind of rocks are showing or when those rocks are dated back to and things of that nature. So it gives us geologic information. And these are only going to be valuable if we have the key. So if we take a look over here at our example, what we'll notice that we have these quaternary sediments are going to be in yellow, and you can see where we would find those. So if I was looking for something that was going to be in a tertiary fossil, then I would want to look for tertiary sedimentary rocks in these light greens, and I might want to spend a lot of time in this area over here, but it would be pointless for me to be in this area over here where it just wasn't the right time frame. So a geologic map gives us an idea of the rocks, the outcropping of the rocks that's showing. So it can give us a clue as to what we're looking at in that area. Okay, the last topic of this lesson is going to be on satellites and technology and how they have helped us get a better representation of the Earth, a better view of the Earth per se. And you can see that there's a whole bunch of different kinds of satellites, and you can go through in the lesson and read what those are. But basically it just gives us more observations, more data, and we're able to get a better picture, create a better model of the Earth from these. All right, well that's it for this video. As always, good luck on the lesson, and we'll see you in the next video.